I figured we could go over the coefficient of variation today. Pretty simple and straightforward calculation. Once again, here are our returns. And once again, in the beige is what's given beforehand to us. So we have 8, 10, 15, and 20%, 20, 17, 15, and 8%. We're doing the same thing on both sides. Um, right here, these two are doing the exact same thing, but one's using a function and one is mechanically calculated. So one of these, this is the average function, which does the same thing as if you added all of them up in parentheses and divided them by the amount of variables that you used, which is 4 in this case. And you do that for both, whichever way you want to do it. You don't need to do it. I did twice. You can just pick one of the ways. And then that is for our expected value, aka our average. Now we can go to our standard deviation. Once again, this is going to be a function, a full function calculation pretty much. You take standard deviation S of your 4 variables that were given without having to put in the number of variables. You get 5.38. All you got to do is then pull that over here, and then you have 510. You have both of your answers from one calculation. Now, for coefficient of variation, all you do is you're going to take your standard deviation and divide it by your expected value, and you end up with 40.58%, and you just have to drag this over, which gives you 33.99%. So that's the calculation for coefficient of variation, and there will be more problems coming in about this.